Up, Derek, 13 Series Engineering here, and today we are going to be talking about relationship issues and how to fix them. So if you're having relationship problems, you have come to the right place. Got a comment on increasing the font size of PHP Storm. So I've done that. Hopefully everything's a little more readable. But today we're basically going to be going over just stuff that's in the Symfony and Doctrine docs on relationships. Going to be nothing new, nothing crazy. Just going over the right way to do relationships in terms of fetching or querying a relationship. And I see this done incorrectly and suboptimally like all the time. So I think it's an important thing to address. And then we're going to do another video right after this where we're going to get into some more advanced relationship things we can add to our repositories. But um, we have, this is the associations, doctrine associations for the Symfony docs. And what I really want to focus on here is fetching related objects. This is kind of just what we're going to be implementing today, and nothing different from the documentation. But I see this a lot where you do you get the related entity just like this. And what that's going to do, especially in a get endpoint, this is important because what that's going to do is it's going to run two queries. The first query was to get the product, and just because you're getting the product in the URL parameter, it's running this query. That's what's happening. And then when you go and get product, it's running another query to get the product. So we're going to fix that the way they tell you to in the documentation, which is right here. You have to write some DQL. We're just going to use Query Builder, but when you do an inner join, then you eager load the relationship, not lazy load. So you're only doing one query, and it's a lot more efficient, especially with an inner join. Um, the problem is that obviously you can't always use this when you do three relationships or do when you get into some more complicated stuff. So we're going to address that in the next video though. And right now we're kind of just going to focus on implementing this really quick. I just want to bring everyone up to speed with what's going on. So I have added star and system for entities and repositories, and these are just for the sake of demonstrating these relationships. They're using UUIDs, and so a system, it's like solar system, that has stars and planets, and they're inversed. So star, is has the inverse of that relationship. If you go and get system, same thing with planets. Um, where is that? Yep. And like I mentioned before, um, this is basically, uh, like this is the way you want to build this relationship out with like a parent and then child entities. And the child entities are going to have to talk to each other at some point. But like I said, we're going to address that in the next video, how we can do that just from our one planet entity in our controller. And if we could just look real quick at something. Um, Here's how I always like to build out relationships. And this is where it takes, some time to think about things. You definitely want to take your time and think, um, about how these relationships are going to be used, and what they really mean. I probably want that to be black, right? Make it a little bigger. Uh, where is font color? There we go. Cool. So when you build relationships, I always start with like think about like the biggest thing you're gonna have, and for us it's a solar system, but bigger than that could be galaxy, or it could just be like the galactic region, like we're in the Milky Way, we're in one of the spiral arms or whatever. But you know, um, like taking that you know bigger step out in like finding a base. So for us as solar system, and the next thing we're going to have is we're going to have planets. Um, but we're also going to have stars. And now it would be easy to kind of say, of course, we could have more than one star in a system. Um, and it would be kind of easy to be like, well, the planets are also related to the stars because they orbit the stars. So we could just put planets inside of stars, but then we can get into kind of a tricky relationship. We might have some other things in our system that we haven't built yet, like asteroids or something like that. But you really just want to, condense these things into like what are they actually related to? What does a star actually have as like properties that it could be? If you wanted to get, if we're going to get really crazy with this, we would do something like, I'll change the color here real quick. Um, in our star, this might be too small for anyone on YouTube to see, but in our star, what do you have? You have like, reactions or solar flares or, hydrogen atoms. So like, the relationships are like part of the properties of describing a star. So, planets doesn't really fit into that. The asteroids of the solar system, or comets or anything, they don't really fit into the star. These are all collected into one, you know, like governing body, and that's the solar system. And the solar system doesn't really have any properties except it has like a count of planets, a count of stars, things like that. That's its properties, is the relationship. So this is like what I think is the right way to define uh, these types of relationships, and planets. Maybe we'd have like moons, and a moon might have a property like, like Io or Titan. I think has methane lakes. One of the ones that has like a lake, that would be a property of a moon. So you can keep breaking it smaller and smaller like that, but um, this is to avoid like weird relationship nesting. And we have to be careful. We are going to go over serialization at some point here. But when we get into, going to have to open Docker real quick while I'm talking. Um, when we get into serialization, that serialization is going to get the entities that you choose in uh, in your serializer group. So it's going to do what we're going to do with function notation today manually is like what a serializer group is kind of going to do automatically. And so I think it's a good exercise to do this first. You kind of understand what's happening. Um, and like a good, the right way to do this, the most efficient way to do this, to not have long query times, not have a long endpoint time, and not just have this crazy serialization where you have like these circular basically dependencies of you're just getting the relationships of everything and this and that, and you just end up with this crazy nesting. That, I mean, that can't happen with serialization because um, you include these things into different, you know um, into the same groups, and you end up pulling let's say we do pull star in serialization, and the star that comes, that's related to planets, and so then we grab planets as well, which is related to star, and then we grab star as well, and so it's like then you get this crazy array of nested objects. And I'm trying not to talk about it because we're going to do it next video, but you know as we're doing this, you might be like, okay, but like we might need to get star from planet at some point. How are we going to do that? That we have to build the relationship somehow or write some custom query to do it. And we will kind of write a custom query, but it's going to be a custom relationship. It's going to get us to star, and it's the right way to do it. And there's another really big ORM that you've probably used before that does the same thing. And there's a reason why they do it, and it's a good reason. Doctrine doesn't have the functionality to use I'm just going to go ahead and spoil it. Doctrine doesn't have a through type of relationship built in, so we're going to have to build our own next time to get more into how to access those things um, when you need them. Anyways, if we go and look at our endpoint, one other note real quick is we're just going to be using Query Builder today. So I moved update back to just using Query Builder. We're not going to do any Heradoc or raw SQL or anything like that. Just using whatchamacallit, just using Query Builder. The other thing is I'm going to test out um, so this is using our asset mapping, built-in asset mapping. The ID gets the planet. We're actually not going to be able to do that when we're done. We can do it right now, but when we're done with this, that's not going to work, and we are going to have to use the ID to find the entity. And there's a specific reason why we need to do that. But first, one thing I do want to test out is I want to show you guys the actual queries that are happening, so we can test and see what our SQL actually looks like and actually look at the performance of it. So I saw this obviously on Stack Overflow, but I just want to try it. I don't know if it'll work. I think it's from an older version of Symfony. Um, I need to somehow, you know what, let's do, and you should never do this, but this is just for purposes of the video to, um, this is just for video purposes to try and dump out our queries. And I haven't tested this, so I'm not exactly sure if this is going to work, but I do want to show how many queries are getting used. And so we try to always keep it to one query. Of course, we wouldn't use this on production. Debug stack is deprecated. Interesting. Also deprecated. Yeah, this is from an article somebody wrote about Symfony 2, I think. So I'm just curious if it works though. Okay. Oh, would help if we had everything running. I'm gonna do a Docker compose up, and then, which I think that was already running actually, Symfony server start-d. Cool. Okay. That's fun. Well, we are working. I need to run migrations though. Migration console doctrine. Cool. All right. I just ran the migrations. Oh. Where were we? Interesting. I swear it says that doesn't exist. Because if we found it in auto loading. Okay, cool. So there's no queries here because obviously we are doing, this is executing after we're doing our asset mapper for the planet ID. So I wouldn't expect anything to be in there, but if we go to the planet and get the system, which should be lazy loaded, we should get a query in there from getting the relationship. And we're not. That's fun. I wonder if this just is not using this. If Doctrine's not using the deprecated stuff I'm using right now, I would say that's probably it. Okay, I need to find a new query logger so I can show what's actually going on here. I'll be right back. Okay, so got it sorted out. I kind of did the same thing. Yeah, debug stack, which is the doctrine debug logging that's deprecated, and then I set the current logger to be a new debug stack and blah blah blah. There you go. Just dump it out. We are going to go like, so we can look at this. We probably just want to count those, but we'll look at it first. So if I go and get this planet, which I have a circular the object. I have to edit that out. Okay, I thought I had an issue, but I don't. My relationship's built right. I just need to serialize it correctly. And so I guess we're gonna kind of get into this a little earlier than what I was planning on, but that's okay. And that's serializer groups. Um, so, oh, I don't think we're gonna log queries out correctly, though. I think they're gonna be, well, maybe they will. We'll see. Context here is what we're gonna use to do our groups. And okay, since this is planet, we're gonna want to do like, we could just do a function because that's everything in Doctrine. They don't like the public stuff. Function get groups, which is going to return an array of strings, which is going to be just planets is the only group here that we're going to use. And if we were to get system, so we're just doing this one-sided for demonstration purposes, but when system gets serialized, again, we just want to get the system. We don't want to get everything else with it. And like I said before, we're going to go over that other stuff later. But let's see here in their docs groups. We're going to need to add that as well. This one. Groups. Let's see, stars. What group do I want to include all the stars in? Just the system group. Same thing with planets. Unless the group is system, I don't want to include it. But ID and name is going to get included in both stars and planets and system. and I'm probably doing that wrong. It's like an all, or you can just probably not do this, but this will help. This will prevent that circular reference, and we don't actually need to add the serializer group here in star or in planet. Um, it should be fine. I don't think we actually need to do that, but we can. What you would do is you would just be like, and these should be back denums, by the way. Is that supposed to be an array? I think so. I might be missing something here, but yeah, because we're not, well, we might still need to add this stuff. Let's see. Let's try it first and then see. Yeah, still not happy. Am I using the wrong? Planet. Let's make sure we actually have this. Attribute groups. Cool. Okay. We should be good with with this and planet. Okay. Groups. It's not happy though. So, unfortunately, I don't think we're going to be able to actually see all the queries here. And the reason is, um, one thing I was forgetting was context for the serialization groups. But now that that's working, queries is not showing us really the correct thing. Um, what we're getting from with queries is we are getting the system with the ID and the name, and it's serializing correctly, but it's only showing one query. Um, it's not showing everything else. It's not showing the other query to get the system. That would need to happen. And I think the reason for that is serialization is happening out of this context. So we're not getting the query logged out correctly. Um, this should do this on a service container level, but instead of just continuing to mess with this, it is definitely doing two queries, and the second one is happening during serialization when it goes to resolve system. Um, if we go and dump out, I wonder if this, I just want to see if we have a proxy class here or not. I don't think we will, but system, blah, blah, blah. Yeah, okay. So this is lazy object state uninitialized. So we can see that we haven't done the query yet to get system after we've got planet. And that's our issue, is that we're passing all this stuff to the JSON function, which is going and creating this JSON response, blah, 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 all that stuff. We could make our own, we could make a wrapper for this, and then we could go and check the queries after we do serialization. That's an abstract controller. We could just do that really quick. I kind of want to, but I don't really think it's worth it. It would be good to see. How long is that going to take to just extend this? We like base controller, extend this, and then inject the, or make this somehow take, we could just mess with this. I don't want to. It's not worth it. But anyways, if we could see the logger, or if we're just rendering this out in a twig, using the debug bar and installed Symfony twig and the profiler and all that stuff, then yeah, we could see all the database queries, um, and we'd see that we have more than one. Um, I think actually, I wonder if I just go and resolve this. So let's say I want to get system name. Now we have to resolve this. It can't be lazy loaded anymore. And of course, this isn't going to affect our serialization or anything that we're doing. Okay, so here's our, you can see our second query, um, which is selecting everything from system. We're going to leave that in there we're just kind of like mocking what's happening, um, to try and just like emulate the point at which this is captured. But this is what's actually going on, when we serialize, because we are serializing system, and I don't know if I went over, not star, planet. In planet, we are serializing system. We're serializing the whole planet class in a group, and then system, we just are doing ID and name for planet, star, and system. So um, we have two queries. That's obviously not great, because we can look at our execution time, which that's like next to nothing, but we're looking at tables, that don't have anything in them, and this is all locally. But these times can, if they just even doubled or tripled, then, it's something that could be noticeable. Maybe. Probably not noticeable. We're not even over um, like 1 millisecond. But still not as efficient to have two queries when you start to get into 600,000, a million, 10 million, 100 million rows. So to fix this and do this the right way the first time, we only have to add one function. It says it in the docs. We went over this. When we get the planet, we're going to change this, and we're going to do, um, yeah, we need to do planet repository, um, get with system. It's going to take the ID. Cool. There we go. That's it. And then planet repository. Can get rid of this. That was a failed attempt to also log queries out without the debug toolbar. Get with system, and that's going to return. What should the return type for this be? I guess just mixed, because I mean, it is returning a planet. Yeah, I think we still want this to return a planet. Is that what they did? Yeah, or null. That's true. Might be null. It is nullable. Show create query builder. We can just do excuse me. Let's see. They did this raw because they're doing select p comma c. I'm actually going to modify this a little. And I am not entirely sure. Okay. So you just have to actually separate the arguments. Cool, there we go. If we look here, yeah, we're gonna do from. I think we need the class for that, right? We actually shouldn't. Planet P, or we just really need planet. Well, yeah, planet P, and then inner join system S. Where p.id equals id, set parameter id to id, get query get results. Yeah. Okay, cool. That's quite a lot going on, but we have our parameter ID set, p.id, inner join on system s. I think this will work, but let's find out. So it might not. Not happy. Class planet is not defined. Right. I think we have to do this in doctrine speak. Oh, and this inner join is probably not correct. Um, so yeah. All right. We want to do p dot system. Um, yeah. P dot system on s. La, la, la. Still don't think that's right. Join alias condition type index type. I think it will default to IDs. So let's try it. Not happy. What did we do wrong? Equals ID, set parameter, p.id. I think there might be an issue with my joiner. I'm going to fix this real quick off camera, and I'll be right back. Okay, so just a syntax error. It's just supposed to put p.system. It joins on the IDs automatically. And there we go. It's working. And you can see we only have one query that is with the join involved in it. And we still have all of our stuff. So there you go. That is this was way longer than I was hoping for. But this is, how we how you're supposed to do these relationships to optimize, your uh, to optimize your query results. I obviously don't need this stuff anymore because we know what it's doing, but um, this is what it kind of looks like without all that garbage that we don't really need. Um, just to recap, so in Planet service, we just are using get. We're not using the asset mapper anymore, or object mapper, whatever it was in the repository. We now have a join to get with system. So when we're getting it, it loads all the data for system for us into the related class. And then we also have group serialization to prevent circular um, circular relationships from loading, which I'm definitely not a huge fan of this myself, but that is one way to do it. That's something that's the one thing I don't like about Symfony is they kind of recommend doing this, and I think it would just be better if it didn't serialize the. We could set this up to not be inversed, but then you would still want to get um, you would still want to get when we query system, we still want to get planets and stars. So we need that relationship there. It needs to be multi-directional. But I wonder if we took inversed out, still getting a system, but then I think it would kind of do the same thing and just not serialize planets when we get a system. So either way, this is fine, uh, not a bad way to do things. Um, the point is that we cleaned up database queries, so we just have the one. That's the entire point, is that we're just doing one thing instead of lazy loading when we go and serialize. So I didn't actually go and compare response times. I kind of want to do that real quick before we're done here. Just gonna put everything back the way it was. Um, this isn't really fair to do that because we're like, well, I guess it kind of is. It doesn't matter that that's in there. It's not going to really slow it down a noticeable amount because we have to load the system at some point, um, whether it's being serialized or not. But it doesn't matter if this is in here or not. Maybe just for sanity, we'll take it out. Um, and then repository, we're going to change this to just being fine. So it's just a normal one. Okay, so this should be back to the normal like lazy relationship. Uh, yeah, that actually went down. I think that with the data size we have, we're not really going to be able to notice a difference with queries, but you will be able to when you have something scalable. Because you're not executing both queries and when you have more columns, when you have more things, more indexes, performance degradation. It's just hard to show with like, yeah, we could like load fixtures and add like a million billion rows to this, and that would probably be a good thing to do to test it. But anyways, this is just, it's like try it on your own thing that's slow and tell me if you get a performance difference, which you should. You should get a big performance difference by um, an inner join versus two separate queries. Um, but yeah, that's all we got for now. Next time we are going to go through the where or the through relationship. So it's going to be pretty fun. Can't wait. But that's everything cleaned up. There's no, you know, nothing special, just some code that we wrote, and that's it. I'll catch you guys next time.